Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac City, Philippines. And tonight we're starting a three-part series in the tools of integration. So this is a Calculus 2 course. And tonight we're specifically talking about U-Substitution and Trig Substitution. So let's get after it. You're going to like these. U-Sub especially will be your friend. Okay, so U-Sub, what do we have this problem? 3x to the second power secant squared x cubed dx. Whoa. What to do? Okay, you'll recall if we were using the chain rule, we would have an inside function that had some function performed on that. And if we were taking the derivative of that, that would equate to the derivative of the outside times the derivative of the inside. Okay, in integration, we're doing, or especially U-Sub, we're doing the opposite of that. We're going to focus on this function and see if we can gain insight into the rest of the problem with that. So let's try that. Okay, so in this case, if I look at the inside, I'm going to let u equal x cubed. So let's just put that here. Okay, u equals x cubed. Well, du then, du, okay, we're going to use the general power rule. You know me, I'm a rules guy. The general power rule and the chain rule. So bring the 3 down, x to the 3 minus 1, which is 2, times the derivative of x. So we're looking at the inside, so that's dx. Now I have a dx here, and I'm wanting to replace these things and go from the x world to the u world. So let me divide both sides by 3x squared. So dx equals du over 3x to the second power. Okay, now let's fill in the blanks here. So we had 3x squared secant squared of u. We said u was x cubed, so we can replace x cubed with u. And then we need to replace dx. Well, dx was du over 3x squared. So that's du over 3x to the second power. Oh, you'll notice this, divided by that, they cancel. So now I have the integral of secant squared u du. So we know from our trig identities, our derivatives, and this is super important to know your derivatives because the opposite of that is integration. So I know the derivative of tangent is secant squared. So if I'm integrating secant squared, it gives me tangent. So this equals tangent u. Well, what was u? U was x to the third power. So the results of this is tangent x to the third power plus c. And that would be the solution for that integral. See how U-Sub works? I mean, before U-Sub, I would have no idea what to do with this. But U-Substitution allowed us to get it, look inside that function, the inside bracket, see if I can take that, substitute u, take its derivative, and see if I can cancel other items in the problem. So that's U-Sub, okay? All right, let's go on to one more. And this is trig substitution. So we have the integral of 1 over 1 plus x squared dx. Now we just used u as a substitute, so why don't we just guess u again and see what happens? Okay, so u If I let u equal x squared, du equals 2x dx. So now du over 2x equals dx. Uh-oh. This doesn't work at all. I mean, at all. So that's not the path to take. So U sub would not work in this case. What about trig sub? If I think about this problem, it's really a 1 over, if I let a, let's say for example, a equals 1. I have a squared plus x squared dx. Okay, if I let x equal a tangent theta, dx equals, this is the constant multiple rule, I can say here's a times the derivative of tangent, and that's secant squared theta d theta, so chain rule. I can replace x with a trig function. So now 1 over a squared plus x squared, and x was a tangent theta squared, but I have dx, and that equals a secant squared theta, and I'm differentiating all of this with respect to d theta, or integrating with respect to theta. Okay, let me square this. A secant squared theta over a squared plus a squared secant, tangent square. Getting ahead of myself here. Tangent square theta. Okay, so what do we got here? We've got terms we could factor in this denominator. So let's see, we have the integral of a, I'm going to pull that a to the outside also. A times the integral of secant squared theta, integrating with respect to d theta. If I factor a squared out, it's a squared times 1 plus tangent square. Ooh. What's 1 plus tangent square? Secant square. So let me pull the a square out. So I have a over a squared, which gives me 1 over a. The integral of secant squared theta over this in the parentheses becomes secant square. Secant squared theta, all to the d theta. Secant squared theta over secant squared theta is 1. So now this thing is going to get down to nothing. Looks like the integral 1 over a times the integral of d theta. Okay. So 1 over, well, what does that equal? 1 over a times theta. And you may be thinking, but not yet. We're still in the theta world. We've got to get back to the x world. Oh, well, let's think about that here. We had x equals a tangent theta. So I can divide both sides by a. So that gives me x over a equals tangent theta. And you know from your trig work that the tangent inverse of x over a equals theta. So now theta is tangent inverse x over a. So the results of all of this is 1 over a tangent inverse x over a plus c. That, my friend, was trig substitution. That is a great tool. Now, eventually, some of these you'll just learn oh, when you see that, that's the answer. It's like 5 times 5. So you won't have to do all of this work to get to it. There's probably 10 or 12 of them, well, at a starting point that you need to memorize. So we just went through U-Sub and Trig Sub and tried to show some examples of this. Now in the future videos we'll do partial fractions and long division, and then a video after that, integration by parts and completing the square. So those would be 6 primary tools or methodologies for integration that we need to really get under our belt, get good at them, and so that we can work some more complex problems. Hopefully you enjoyed the video of U-Sub and Trig Sub. Why are we doing this? Because together we want to build a better world, and we want to do that through math. So that's all for now, and we'll talk to you next time. Thanks.